Hi, this is Prob 19 from the AMC 12A. Jerry starts at 0 on a real number line. He tosses a fair coin 8 times. When he gets heads, he moves 1 unit in the positive direction. When he gets tails, he moves 1 unit in the negative direction. The probability that he reaches 4 at some time during this process is the reduced fraction a over b, and we're trying to find the sum a plus b. Boy, tricky problem. Let's try to draw a few figures to see if we can understand this better. Let's draw a number line from 0 to 4, and I guess we can go to -4 if things work out a certain way. And let's see, so we're starting at 0 initially, and every time we flip the coin, we're going to go either one step to the left or one step to the right. And then when we flip the coin a second time, we're going to go again one step to the left, one step to the right. And the third time we're going to do the same again. And the fourth time. And the fifth time. And the sixth coin toss. And the seventh coin toss. And finally the eighth coin toss. And it seems like what we're looking for is what is the probability that we're going to reach 4 at any point during this process. So essentially we're trying to see what's the probability that during this process of dribbling down this lattice, that at some point in the process we're going to end up in this region to the right. It's kind of what it comes down to. Now that's kind of a difficult counting process because it seems like there's a lot of different ways that we can get there. For instance, if we were to just look at the probability of getting to some lattice point at some predetermined number of tosses, that's pretty easy, and that's actually determined by Pascal's triangle, and we'll kind of work that out in a second. So it seems as though Pascal's triangle is probably going to help us work out what's the probability of getting into this region in the right. So let's try to draw out Pascal's triangle. Let's see, we have 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 6, I'm sorry, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. I don't think we need the left side, but let me just draw it in for the heck of it. 6, 1, 1, 7, 21. 8, 56, 70, 56, 28, 8, 1. Okay, so now we can try to work this out. The first thing is let's try to work out the probability of just getting to this fourth point on the fourth toss. That looks like to be the easiest one to calculate, so let's just go ahead and do that one first. So the probability to get to this lattice point is just 1 divided by the sum of these numbers, and the sums of these rows works out pretty easily to be factors of 2. So let's write those out. That's 2, 4, 8, 16, 32, 64, 128, 256. So the probability to get to this lattice point is just 1 divided by 16. So let's write that out. And now let's see, how do we get to the lattice point for the sixth toss? And it seems as though this is a little bit tricky to calculate now because we've already calculated the process to get to this lattice point, and we don't want to double count the process by which we go through this lattice point and then get to this lattice point, having already gone through this lattice point. So we really want to calculate the process of getting to this lattice point without already have gotten into this region in some previous toss. And the only way to do that is to get to this lattice point and then make 2 right turns. And the probability of doing that is the probability of getting to this lattice point times 1/2 times 1/2. the probability of getting to this lattice point is 4 divided by 16 times 1/2 times 1/2 is equal to 1/16. So that's the calculation for these two lattice points now. Now this third lattice point is very tricky because we want to calculate the probability of getting to this lattice point without double counting how we got to lattice points above. And the only way to do that basically is to see that the way to get to this lattice point is to either get to this lattice point and make 1, 2, 3, 4 right turns, or to get to this lattice point and make 1 left and 3 right turns. And those seem like two processes that we can add. So let's take this lattice point. The probability is 6 over 16, and 1, 2, 3, 4 right turns, and add the probability of getting to this lattice point, 4 divided by 16, and making a left, right, right, right. So that's equal to 10 over 256, and that's equal to 5 over 128, and 1/16 is equal to over 128, and this is equal to 8 over 128. So adding up these three different processes, we find that the total probability of getting into this region is now 8 over 128 plus 8 over 128 plus 5 over 128, 23 over 128, and that's a reduced fraction. So the sum of the numerator and denominator is 23 plus 128. That's 151 for choice B. Anyway, a very tricky problem. This is actually done a little bit differently by the AoPS guys, so check out that solution as well. And good luck with that, and we'll see you at the next video. Take care. Bye.